faster. There it is, lads.
Land ho!
Let's head to the debriefing room. Okay. All right, lads. What have we got here? How are we going to get to this village?
So, Navigator TI has found some very important information. We're right there. The village is over there. Now, he has devised a way to find the fastest time to travel from our ship to the village. Could you explain?
So in order to avoid the cannonballs that the village has, we have to get there as quickly as possible, and that means finding the right place on shore. The village is over here. We are 50 meters along the shoreline away from the village and 10 meters off the shore. So we need to find this point where we can get there the fastest, because we can only run at 3 meters per second, and we can only row at 2 meters per second. Let's do some calculus. So in order to optimize the time that it would take to get to the village over here, use the D equals RT formula. Total amount of time it's going to take them is the distance they have to travel divided by the rate at which they move. We can take the first distance that they have to travel, which is going to be from their starting point to somewhere along the shore, and say that 10 squared plus x squared is going to equal this length here squared, divided by the rate that they travel on that line, plus 50 meters minus that distance, divided by the rate will give you the time. We have this equation, which is modeled here. We can find where the derivative is equal to 0, which would be down here, and at that minimum is where the time would be the least.
All right. So what's your answer then? Yeah.
Well, you see, we're going to have to land 8.944 meters east of where we currently are relative to the shore.
Excellent work. Of course, could have come up with it on my own. Good work, nevertheless. Thank you, sir. Now let's get going. All right, lads. We've made it to the village. Now let's get that... Hey, that's the guy that's got the treasure. Let's charge!
Take my calculus.
Yeah!
Take my math.
Yeah!
Yes!
Run!
No.
Yeah, let me see that. Hold this. Oh my god. This is the map of Barbusa. His hidden treasure. Lads, we've got booty coming our way. Get back to the ship. Now, onward to the treasure. We're still rowing slowly.
Sorry, Captain.
You hear that?
Sounds like water.
Oh my god, there's water! It's coming into the boat! There's a hole!
Uh-oh.
Start scooping! Start scooping!
If the water is coming in the boat at a rate of 9t squared gallons per second, and L'Hôpital is bailing at a rate of 2 e to the t gallons per second, we can model the total rate of water coming in or out of the boat by subtracting the two equations. Then if you want to find the total water at 5 seconds, you can integrate both equations and subtract the integrations so that you get 80 gallons in 5 seconds.
Scoop it. It's a hole. It's a removable discontinuity.
What are you
you
talking
idiot.
about?
I'm mutiny.
Wait. Mutiny? How could he mutiny? That... Mutiny? A revolution. Revolution.
Things do well. It all depends on you for me to get your recommendation. Thank you very much.
Oh no. I thought I'd studied.
Time's up. Sorry.
No, I just started.
Nope, too bad. Paper, thank you very much. Paper, thank you very much. Paper, gracias. John L'Hopital. For shame.
Oh no. Oh no. Oh God, no! No!
I thought I taught you this lesson.
No.
Let the area R be defined by the x-axis, the y-axis, and then r of x, which is negative x squared plus 4. To find the area, first you have to find the integral from 0 to 2, which is the starting and ending point of the graph. That you take the function, all multiplied by the derivative of x, meters squared. To find the volume, since you're revolving around the y-axis, you have to multiply by pi times the integral from 0 to 4, which is the starting and ending point of the graph if you rotate it around to be the y-axis of the function, which is root 4 minus rx, all squared times the derivative of r of x. And that becomes 8 pi meters cubed.
Not another revolution. I can't have another revolution. Oh no. He's gathered the crew. It may be too late.
Captain L'Hopital is an imbecile and a fraud. I've never seen someone so bad at calculus in my life. Not to mention, he keeps making us row a sailboat. He is an idiot! Join me, Nicholas Pedicus, and restore glory to a pirate name. We need to mutiny against Captain L'Hopital.
Yeah.
Nicholas Pedicus gains pirates at the rate of P of T equals 3 plus 6 times T squared over 2. Captain L'Hopital gains 2 loyal pirates per hour from the time of 0 to 24, and he starts with 25 loyal pirates. So at the end, we integrate to get that Nicholas Pedicus will have 77.188 pirates, and L'Hopital will gain 73 pirates. But since Nicholas Pedicus has more pirates than L'Hopital, the mutiny will overpower L'Hopital's pirates.
Hey, no, don't. This is a bad idea. I'm the captain.
Not
You can't-
anymore.
No, this.
Not anymore.
It's not. No, you can't.
Goodbye,
No.
Captain L'Hopital.
Why? No. I swear silver. Nicholas, Pedicus, you traitor. Adventurer. Oh, I made it. Good thing. In this one particular circumstance, this is a good thing that I spent all of my time in pirate high school on the swim team instead of studying calculus. And even better than that is that I remembered to bring the map. Now, how do I get off this island? Oh, what do we have here?
Hey.
Island dweller, nice. Oh, is that a boat you got there? Yeah. Nice boat you have. Hey, do you like hide and seek?
Sure.
Alright, so I'll hide and you count.
Okay.
Alright. really hard. Why didn't I just buy a new sail?
Look at how fast we go now. Thank you, Captain, for the new sail.
No problem. L'Hopital never would have gotten us a new sail. Is that him? Is that L'Hopital?
Is that Pedicus?
Is he rowing to the treasure? He's never gonna get there.
How does he know where the treasure is?
It's a good thing I remember the map of Barbusa.
Looks like it's gonna be a treasure race. But how am I gonna know who's gonna get there first?
He can't even calculate who's gonna get there first.
I'll have to do it, won't I? I'll have to use calculus.
Nicholas Pedicus and Captain L'Hopital are racing to the treasure. Nicholas Pedicus is 7.5 miles west and 1.5 miles north of the treasure. Captain L'Hopital is 8 miles south and 2.6 miles east of the treasure. Solve for the third side by Pythagoras. Set up a related rates problem for each of them based on how fast they're going. So Pedicus is going south at 0.4 miles per hour and west at 3. Use the Pythagorean theorem, take the derivative, and then plug in all your values to solve for the rate at which he is going on this diagonal. You're going to do the same for Captain L'Hopital. For Nicholas Pedicus, you get that he's going at 3.02 miles per hour. So if he has to go 7.649 miles to the treasure at 3.02 miles per hour, it'll take him 2.533 hours to get there. For Captain L'Hopital, he's going at 2.07 miles per hour because he's only rowing, he doesn't have a sail. To go 8.412 miles at 2.087 miles per hour, it'll take him 4.03 hours to get there. So Nicholas Pedicus is going to get to the treasure first thanks to his superior calculus and pirate skills.
Seems he'll get there first, which means I have to row faster.
Look, crew. The treasure of Barbusa.
Yes, fine. Pedicus.
L'Hopital.
Hi, how are you? Good. I have a small problem though. I got a little traitor who wants to take my treasure.
The treasure's mine.
There's only one way to settle this. On guard.
Never get the treasure.
The treasure is mine. A traitor like you doesn't deserve it.
It's mine.
No, it's mine.
Dissy that.
What?
Crabs.
What?
Crabs!
Oh,